Hi Flashes, today we are going to be going through our proportional reasoning topic here over graphs and tables and equations and some ratios. So this is just a good review over everything that we have talked about so far. So I have these little task cards here, so I am going to put them into their boxes that go with each one of them. So the first ones that we're talking about are graphs. So I'm on my proportional reasoning graph questions, and this is question number 1. So the first one here says, explain how to determine if a proportional relationship exists between two variables in a graph. So what were the two requirements that we talked about in class that makes a graph proportional? Well, one of them was it had to be a straight line. So in order for a graph to be proportional, it had to be a straight line, which means that it had a constant rate of change. And our second requirement was it had to go through our origin, through the origin. And remember, the point 0, 0 is what we represent as the origin. So as long as the graph is a straight line and it goes through the origin, we say that it is proportional. So there's our first task card. Moving on to question number 2. They're wondering, does a proportional relationship exist in this graph, and explain. So looking at this graph, we just said that in order for a graph to be proportional, it must go through the origin and it must be a straight line. So I see that my line is a straight line, and I see that my graph does go through the point 0, 0. So this is a proportional graph. So I'm going to put proportional. And then they tell me to explain, so I'm going to put because the graph is a straight line and it goes through the origin. And remember, guys, you must write down both things because in order for a graph to be proportional, it must have both requirements. It must go through the origin and it must be a straight line. So there's number 2. And number 3, so number 3 says, explain how to find the constant of proportionality from a graph. So in order to find the constant of proportionality, we are going to pretty much be finding the slope of this line. Because remember, we talked about constant of proportionality within direct variation. And direct variation means you have a proportional slope. So you have a graph that goes through the origin, and you can be able to find the constant of proportionality by finding unit rates or by just finding the slope itself. Okay, so I am just going to explain that. Over here for number 3, so they don't tell us to actually find out what the constant of proportionality is, but something that I could do is choose 2 points on this line and then find the slope of it. So if I were to choose this point and this point, I would be going up 2 over 1. So my constant of proportionality would just be 2. So explain how to find the constant of proportionality from the graph. I can put, I can find the slope of the line, or I can find the unit rates of an ordered pair. So there's a couple different ways that I can figure out what my constant of proportionality is from the graph. But or there. Alright, and then moving on to number 4. So does a proportional relationship exist in this graph and explain. So remember, in order for this graph to be proportional, is it must be the straight line and it must go through the origin. So I do notice that I have a straight line. However, my graph does not go through the origin, so this is non-proportional. So we'll write non-proportional because the graph does not go through the origin. All right, so those were some good review questions over proportional reasoning with graphs. So let's go ahead and move on to proportional reasoning with tables. All right, so first question here is explain how to determine if a proportional relationship exists between two variables in a table. So if you guys remember, when we try to figure out if a table was proportional or not, we had to find the unit rates. So what we did was we took our y divided by our x value, and if we had constant ratios every time when we did that, that meant that we had a proportional relationship. So to explain that, I would put we had to find the unit rates by taking our y divided by x. So I'm just going to write it like this, y divided by x. And if we had constant ratios, we had a proportional relationship. All right, so now we are going to move on to number 2. So does this table have a proportional relationship? So remember, all that we did was we were taking our y divided by x every time and finding the unit rate to see if they were all equivalent to each other. So I'm going to use this space over here off to the side. So the first one, the 0 and the 5, so again, I'm going to take y divided by x, I'm finding the unit rate. And as you can see, whenever I take 5 divided by 0, I get an error because this is what we call undefined. So this first one isn't going to work for us, but we can go ahead and try and figure out our other ones to see if those have unit rates that are constant or not. So our next order pair is 114. So if I were to take 14 divided by 1, that gives me a unit rate of 14. Then I'm going to do the same thing with my second order pair. So I'm going to take y divided by x, which is 23 divided by 2. And I get 11.5. So I know right away that I'm not going to get constant ratios because 14 divided by 1 was 14, but 23 divided by 2 was 11.5. So I already know that I'm not going to have all the same unit rates. So I know for sure that this is non-proportional. So non-proportional because we did not have constant ratios, or you can even put constant unit rates. All right, moving on to the next one. So explain how to find the constant proportionality from the table. So again, constant proportionality is just finding out what the slope is of the graph. And we know that if we're talking about constant of proportionality, we know for sure that this is already a proportional graph, so we just need to know what's the unit rate. So again, all that we are going to do is we are going to take our y divided by x by finding that unit rate, and then just figuring out what that constant of proportionality is. So if we, again, don't worry about the 0, 0, but just worry about the other ones. So if we were to take 6 divided by 2, that gives us 3. 9 divided by 3 gives us 3. 12 divided by 4 gives us 3. And 15 divided by 5 gives us 3. So notice how when we found the unit rate, we got a constant ratio of 3. So our constant of proportionality then would be 3. So we would put, we found the unit rates of the table and found our constant of proportionality to be 3. And you can even write down those ratios to show that it was 3. So we took 6 over 2, 9 over 3, 12 over 4, and 15 over 5, and all of those were equivalent to our unit rate of 3. Alright, and last one here. So does a proportional relationship exist in the table? So once again, all that we're doing is we are finding our unit rate by taking our y divided by our x's. And again, whenever there's zeros, don't worry about those, okay? Alright, so first one here is 4 over 1. So 4 over 1 is equivalent to 4. Next one is 8 over 2. And if we were to take 8 divided by 2, that also gives us 4. Next one would be 12 over 3. And 12 divided by 3 is 4. And then the last one is 16 over 4, which again, 16 divided by 4 also gives us 4. So notice how we had constant ratios, so that means that we did have a proportional relationship. So I would put proportional because we had constant unit rates. And we know that the graph starts at 0, 0 because they told us that we do have that point 0, 0, which is our origin. Alright, so that is proportionality from a graph in a table. So now let's move on to verbal description questions. Alright, so in a verbal description, they want to know, explain how to determine if a proportional relationship exists between two variables in a verbal description. So in other words, how can we tell if there is going to be a proportional relationship when given a word problem? So like, what are we looking for in a word problem? Well, we're looking for if they told us a constant rate of change. Like, did they tell us it was, if Henry was babysitting, did they tell us how much he makes an hour? Because that would be your constant rate of change. Or if someone was talking about them driving and they're talking about miles per gallon, that too would be your constant rate of change. So what we're looking for is we are looking for a constant rate of change. Because if they give us that constant rate of change, then we know that it will be proportional. All right, moving on to the next one. So Bill drove 240 miles in 4 hours. On another day, he drove 480 miles in 8 hours. What is the constant of proportionality? So remember, to find the constant of proportionality, we are just finding a unit rate. We are finding the slope, and all that we're doing here is taking the unit rate. So this is going to be miles over hours. So they said that Bill drove 240 miles in 4 hours, we can find this unit rate by dividing. So if we were to take 240 divided by 4, that gives us 60. So this would be 60 miles in 1 hour. Then we can do the same thing just to make sure that it was constant by taking the 480 miles in 8 hours and seeing if we get 60 again. So 480 divided by 8, notice how I do get 60 again. So our constant of proportionality here will be this 60 miles over 1 hour. Number 3, Aline swam 7,500 yards in 2.5 hours. How far can she swim in 1 hour? So as soon as you see that 1 here, we are looking for a unit rate. Okay, that unit rate is going to tell us what our slope is. So remember, time is always indicated as your x value. So to find our unit rate, we are going to take the 7,500 yards divided by our 2.5 hours, and unit rate means that we're just dividing. So 7,500 divided by 2.5 gives us a unit rate of 3,000 yards per 1 hour. Alright, and last one here, number 4. Adam ran 3 miles in 30 minutes. If he continues at a constant rate, how many miles can he run in 2 hours? Okay, so a couple different ways that we can do this. One way is to find the unit rate, and then we can multiply from there to figure out all the hours. To figure out how many miles he can run in 2 hours, or I can set up a proportion. So when I set up my proportion, remember everything has to be aligned in a proportion. So let's say my 2 variables here are miles and minutes. So I'm going to put miles in my numerator and minutes in my denominator. And I'm going to set up my first proportion. So they said that Adam can run 3 miles in 30 minutes. So since I'm putting miles in my numerator, I'm going to put the 3 up top in the numerator. And since I put minutes in the denominator, I'm going to put that 30 minutes down here in the denominator. Okay. Now they're wanting to know how many miles can he run in 2 hours. So I'm not going to put 2 up here in miles because the 2's not talking about miles, and I'm also not going to put the 2 down here with minutes because this 2 is talking about hours and not minutes. So I'm actually going to have to change this 2 into minutes so that I can put a number down here to make sure that everything is proportional. So let's figure out how many minutes are in an hour. Well, there's 60 minutes in an hour. So if I have 2 hours, how many minutes are in 2 hours? Well, just take 60 plus 60, and we get 120. So 2 hours is equivalent to 120 minutes. So I'm going to put 120 minutes down here to make sure that I keep everything aligned. And what we are trying to find is how many miles can they run in 120 minutes. So now that I set up my proportion, we can go ahead and solve. So 30 times x is 30x. 3 times 120 is 360. And last step is to divide both sides by 30 to get that x by itself. So 360 divided by 30 gives us 12 miles. And that is how you find proportional relationships from a verbal description. All right, so now we are going to be finding proportional relationships from equations. So remember our equation that we talked about was with direct variation, and that equation was in the format of y equals kx, where k was your constant of proportionality, so in other words, your slope. So when we're talking about equation, equation y equals kx, and then our slope, or in other words, our constant of proportionality, will be filled in for k. All right, so first one here, Patricia drove at a constant speed for 5 hours. She drove 325 miles. What equation could be written to find how many miles she can drive in 9 hours? So the first thing that we need to do is figure out, well, if I know that my equation is going to be y equals kx, I need to know what is my constant of proportionality. So just like we did up here, we had to find the rate of change by taking unit rates. So our first unit rate here, again, time is always in the denominator because that's representing your x value, because you can control the time, you cannot control the miles. So this is going to be 325 miles over 5 hours. Okay. And remember, when you're finding unit rate, we are just dividing. So we're going to take 325 divided by 5, and we get 65 miles in 1 hour. So our slope, or in other words, our constant of proportionality, is going to be this 65. So if I wanted to create my equation now, I now know what my constant of proportionality is. It is just the 65. So again, in my equation, I'm always going to plug in this constant of proportionality in for k, and then just rewrite the equation. So our equation would be y equals 65x. So now that we have our equation, let's figure out how many miles she can drive in 9 hours. So remember, x was being represented by hours, so I am just going to plug in 9 for x, and then just solve it. So 65 times 9 would give me 585 miles. So in 9 hours, she can drive 585 miles. Okay, moving on to number 2. Write an equation for the data given in the table. So for this equation, again, we just need to find our constant of proportionality by taking our unit rates, and then we are going to plug it into this y equals kx equation. So first thing here is figure out our unit rates. So we're taking y divided by x. So first one is 4 over 1. Next one is 8 over 2. Then we have 12 over 3. And then we have 16 over 4. And remember, when we're finding unit rates, we are just dividing. So 4 divided by 1 is 4. 8 divided by 2 is 4. 12 divided by 3 is 4. And 16 divided by 4 is also 4. So what was our constant of proportionality? 4. Okay. So again, when you have your equation, your constant of proportionality is represented by k. So all that we are going to do is we are going to plug in 4 for k and create our equation. So our equation here is going to be y equals constant of proportionality 4, and then your x. And that's your equation. All right, number 3. Explain how to find the constant of proportionality from the equation y equals $3.50 x. Well, we know from our equation y equals kx that your constant of proportionality is always being multiplied with x. So in this case, our constant of proportionality would be that $3.50. So how did we figure that out? So the constant proportionality is the number being multiplied by x. So in this case, it was the $3.50. All right, and last one here, write an equation for the data given in the table. So again, just like we did up here in number 2, we need to figure out what our unit rate is, what is the constant of proportionality, so that we can plug it in for k and rewrite it to create our equation. So what we're going to do here is find the unit rate by taking y divided by x. So our first one is 6 divided by 2, which is 3. Next one is 12 divided by 4, which is 3. Next one is 18 divided by 6, which is 3. And the last one is 24 divided by 8, which is also 3. So as you can see, we had a constant rate of change, we had a constant of proportionality, and that constant of proportionality was 3. So in our equation y equals kx, I'm going to plug in my constant of proportionality in for k and rewrite the equation. So our equation here is y equals 3x. Alrighty, moving on to our last section here, which is on ratios. So our first question is explain how to determine if two ratios are proportional. And if you guys remember when we solved a proportion with a ratio, so that's what we did up here with cross products, in order for ratios to be proportional, those cross products have to be equal to one another. So we say that two ratios are proportional when the cross products are equal to each other. Or you could put, like, when you simplify your fractions, they should equal each other. That would be another description on equivalent ratios. All right, number 2. Given the table, write 3 ratios that are proportional, okay? So when we're writing ratios, we know that unit rates are going to be proportional. So I could just write these unit rates, and I could say that they are the same, because if I take a unit rate of 4 over 1, a unit rate of 8 over 2, a unit rate of 12 over 3, and the unit rate of 16 over 4, notice how if I were to divide all of these, they would all equal 4. So we would say that all of these fractions are equivalent ratios, that they are all proportional to one another. All right, number 3. Your friend says that she ran 4 laps in 28 minutes. You ran 2.5 laps in 17.5 minutes. She says you ran at the same rate. Do you agree? So let's see if, so there's a couple different ways we can do this. We can set up a proportion and do our cross products to see if they equal each other, or we can just find each unit rate to see if they equal the same thing. So again, she ran 4 laps in 28 minutes. So 28 minutes over 4 laps. Because I can control my laps, so that's why the laps is in the denominator and my minutes would be in the numerator here. So if I were to find this unit rate, 28 divided by 4 would give me 7 minutes and 1 lap. And the other one said you ran 2.5 laps in 17.5 minutes. So 17.5 minutes over 2.5 laps, and again we're just going to find this unit rate by dividing. So 17.5 divided by 2.5 would once again give me 7 minutes over 1 lap. So do you agree that you guys ran at the same time? Yep, we agree because we have the same unit rate. Alrighty, and our last question here. Determine the value of x and round to the 10th place. So again, when we are solving a proportion, we are using our cross products. So here, I'm taking 30 times x, which is 30x. Then I'm taking 65 times 4, which is 260. And then to get x by itself, we are dividing by 30 on both sides. So 260 divided by 30 gives me 8.6 repeating, and if it tells us to round to the 10th place, so if I had 8.6 repeating, I would have 8.66. The 10th place is the first number after the decimal, so I'm going to look one number behind it. If the number behind it is 5 or greater, then I'm going to bump the 6 up one, which in this case I am. So our answer is going to be 8.7. All right, so this is a good review over proportional relationships with tables, graphs, equations, word problems, and some basic ratios questions. So if you guys have any questions, please let your teacher know.